do descriptive statistics, and then tell me if the series you chose, and I didn't restrict you to choosing any series. I said I just choose whatever series you want. I give you the time period, and then after doing a few things, I want you to test whether that series comes from a normal distribution. Okay. I see your hands raised. I will answer questions as I go on. I just want to just hang on. Okay. If you have your hands raised, just hang on. All right. So I want to share the screen. Homework number one. Okay. So this is the homework number one. Everybody, if you haven't done so already, you should have at least gone to page 12 of the textbook. You should have played around with, downloaded those 4 packages I have suggested you download. Those are the things, you don't use them all, but you use QuantMod and you use F Basics. F Basics is part of, I think it's part of Zoo or part of one of the programs, okay? So what do I want you to do? Every question I asked here, every question I have asked, I have stated here, you can, there are examples there on these pages from page 12 to 20 or page 25 to 27. And all these examples are too many commands, because what I asked you to do here is just a few commands from these pages. So I want to point them out to you today. I just put all the commands so that in case you run into trouble, you can go to those pages and look through those commands, okay? Now, so each R example in the book is called R demonstration. All right, so this exercise covers sections 1.4 through 1.6. All right, so what did I ask you to do? I said, go and use the QuantMod package to download this data. Now, on page 12, it tells you download QuantMod, download TTS, download XTS, and download Zoo. That's all you need for now, okay? And then download monthly data. So you will go and pick up monthly data, hopefully using QuantMod. All right, now let's see. Just hold on. I know some of you have questions. Let me just run through this quickly, and then I will take all your questions. So this is page 13. That is the page after page 12. On page 12, it tells you to download QuantMod, TTS, XTS, and Zoo. So you have downloaded them, and then this R demonstration says, once you have installed them, installing means you go outside of R, bring the program into R, and just leave it there. Just like when you use Excel, when you buy Excel the first time, there's already, because when you buy Excel the first time, they have brought in many programs and kind of put them in a storage. Put them in a storage. So what I'm asking with QuantMod, I'm sorry, with QuantMod, you bring QuantMod from outside of R and you put it inside of R and you put it in storage. That is what you use the instruction install.packages parentheses quote QuantMod. Okay, that's either that or if you're using R Studio, you go there to the bottom right hand quadrant, that box in the bottom right hand, you say install, you click on install, you bring everything in. We practiced this already. So you bring it in, but after installing, if you want to use it to do your work right now, you have to library it. So library QuantMod, meaning go to the storage where you left it and bring it into R and then begin to work. Just like when you wanted to run a regression in Echo 4000, you went and brought this package we call data analysis, and then put it on the screen. That's the same thing. So here you use library QuantMod. So once you use this command, library QuantMod, then QuantMod is right there at your fingertips, ready to do work for you. Okay, so once you have quant mod, then you use this thing called get symbols. Type it exactly like this, and then use this command. And then I want you to play around with it. This is what I want you to play around with. And if you need to, go to Google and check it out. How do I use quant mod to download data from Yahoo? Okay, so this is get symbol, AAPL, and so on. So I want everybody to do a little bit of homework here. I don't want to spoon feed you every step of the way, but this is what you need is here. And then you can play around with it. Dimension, it tells you, how much data you have. Head, it gives you tail, it gives you the tail. And then I had asked you here to, hold on. Just give me a few minutes. Let me talk this through quickly, and then I'll take your questions. And then I said, download the monthly prices, compute the natural log, and then plot the series, chart the series, chart the price series. So once you download the prices from Yahoo, plot the prices, and then change the prices into log return. Log return is you take log T, log price T, log price February minus log price January. That is the return. Okay, so let me show you. So 3, 4, and 5 here you go. So let me go back and, sorry, I always have to move in and out because my computer is a mess. Oh, this is not what I want. I want the textbook. My computer freezes up. Okay, so here, so look at this command, chart series. Chart series, that's what you use to plot. Okay, that's what you need to plot. All right, and once you say chart, and by the way, if you guys do dimension, and you get the result here in your R program, just leave it there. And then when you do head, suppose your thing is Apple, and I hope many of you didn't use Apple. Think outside of the box, use other things. You get this result, and then you do tail, you get this result. All these results, later I want you to copy everything, including all these commands, copy them, and put them in Word, in a Word file, and save it, okay? And that's what you submit to us. I had a meeting with my TA, with our graduate TA, Chandu. I had a meeting with her over the weekend, and then she and I are going to be grading this, but we're going to be grading from the Word file, okay? It's too complicated to have you submit the program on R. Don't do that. So whatever, so if this page are your results, you copy everything here, okay, and put them in, copy them into Word, save the Word file. You're going to submit it to us at the end, okay? And I know some of you have questions, but I need to go on so I don't waste time. I need to finish describing this. Okay, and then when you use chart series, what I just showed you on the previous page, you'll get these graphs, okay? Just let them be, because eventually you're going to copy them and paste them into Word document. So you're going to get all these graphs, okay? You're going to get the graph, only one graph for the price for your homework, and then one graph for the return. That's all I need. I don't want all this. I don't want unnecessary graphs. Just one graph for the price, time series of price, and then one graph for the log return. All right, so look at this. So here it's playing around with different things. All right, here it's still head and so on, and then chart series. All right, get symbol. The same things you guys have been doing up there. So you can do that again. And then here, I'm sorry, where was I? I'm just going back and forth. All right, I want to show you. I want to go to page 17. Let me go there gradually here so I don't make a mistake. You know what? Let me just type it here. Let me type 17. Okay, so on page 17, Where did I see log return series? Somewhere there, I see log return series. Is it, I'm sorry, not on page 17. On page 20, okay, on page 20 here, I see the log return series. On page 20, let's see there. Look here, up here, down here, it says USEU return equal the difference in log, okay? Difference in log. And usually when I need you to do natural log. So this LOG is natural logarithm. Again, this is discussed in your book. So when I say calculate the log return, what I mean is the log of the price in time t minus log of the price in time t minus 1. So today, log price today minus log price the previous day. Okay, it's discussed in your book. So find the page and read it up. But those are the commands you need. Okay, and then what else? Let's see. Sorry, I want to talk about this fast, and then I'll take your questions. Okay, and then here it says number 6, compute the descriptive statistics using the FBasics package on page 25. Now, the FBase again. So this is where many of you might differ. Some of you already did Echo 4000, and your professor used R. So you downloaded R maybe last year, or sometime last year. But some of you never used R, and you downloaded R at the beginning of this semester. Now, most probably, those are 2 versions of R that you downloaded, because R keeps updating. In the earlier versions of R, the Zoo, the XTS, and the TTS probably do not have FBasics in the core in them, or FBasics is not in the core R program. It happens. But in the later versions, I think once you download either XTS or Zoo, it comes with FBasics. Okay. In fact, if you download Zoo, Zoo comes with its own series of little packages. So the first thing I'll ask you to do before you go installing FBasic, try the command with, say, library FBasics. And if it's not there, it will give you an error message, and then you know you need to go install it. But chances are, if you took Echo 4000 last year, and even if your professor did not use R for you, you did everything on Excel, so you're just working with R now. If you use FBasics, and my suspicion is it will not give you an error because the FBasics is already in one of the packages there. Okay. All right, so this is on page 25. So let's go. So you use FBasics to do descriptive statistics. I showed you how to use FBasics in class. So you have an example program that I remember putting it on Blackboard for everybody a couple of weeks ago. Okay, so you use that to compute descriptive statistics, and I'll show you in a second. And that command to calculate descriptive statistics will give you all the statistics you need, including the 4 moments. Okay, and then I said explain them and then perform the Jacques-Berra test. Okay, so let me go back to the textbook and show you. I'm going straight to page 25. Okay, right here. So let's go to page 25. Okay, let's see. Page, oh God, 25, sorry. I have this thing called Adobe Acrobat, and it's just messing up my my computer. It ties me up. I think it's too, okay, so look here on page 25. God, I messed up. So on page 25, sorry guys, just bear with me, okay? But that's the fun of doing this. I know, stop laughing at me, please. Okay, so here at the bottom of page 25, the R demonstration, it said library FBasics. Once you use library, that means you already installed fbasics. So if you type this library fbasics, now remember, this F is lowercase, and then this B is uppercase. R is very case sensitive. So if you get an error message, don't panic. Look at what you typed. 50% of the time, if you're like me, 70% of the time, I typed it wrong. So check your, we call it syntax. Syntax. Check your spelling. And for R, you have to spell it exactly like this: little f, big uppercase B, little a, and so on. So do this. If you do library fbasics and it gives you an error, check the spelling and syntax. If you typed everything correctly, that means you need to install fbasics. You probably have an older version. But I can bet you, for all of you, I can bet you that if you download Zoo, XCS, and all that, and then you say library fbasics, I can bet you that it won't give you an error message. But if it does, do not be surprised. Okay. All right. So you do library. So this ensures that now fbasics is at your fingertips. So the next thing you do is here. You see here this command: basic stats. Look, lowercase b, uppercase s, no space in between, mm. And all of you notice that that in Excel, not in Excel, in R, you read data and you put it in an address. Okay, and that's it. So if you have long statement to read in data into R, then put it in data. So at least you know that's your data, data one, or data apple, data underscore apple. So you know that it's apple in there. So now if you do that, then you say basic stats parenthesis data underscore apple. Okay, that means you are telling Apple, you are telling R to use the little subroutine, the little package called basic stats, to compute all the statistics for you on the on the Apple series. Okay, but then again, before you calculate basic stats, remember, with the price, you need to convert it to return. So it is the log return that you save in a place, and then do basic stats in that log return. Okay. So when you do that, what result do you get? Oh my God, it gives you everything. See, it gives you a number of observations. It gives you, the minimum, the maximum, first quartile, that's 25th percentile. The mean is the second quartile. The third quartile is the 75th percentile of the series of your numbers. The mean, so the 25th percentile, the mean is the 50th percent, or the mean or the median is the 50th percentile, then the 75th percentile. You have mean, median, the sum, you have the standard error of the mean, you have LCI, all these statistics, but I don't need you to talk about all of them now. But what do I want? The first moment, mean, the second moment, variance, and then square root of standard deviation, the skewness, the kurtosis. So look, with that simple command, basic stats, okay, it computes everything. And then it uses all of this to test whether the mean, it shows you the mean, the variance, standard deviation. Then it does the t-test to test whether those numbers are statistically different from zero. Okay, I don't require you to do it for this homework, but why not? Just run through this. I mean, look, the comments are all there for you, and the results will be there for you. And then just one final thing, okay? And then I can take questions. So all of this, I mean, you can practice with all of this. That's the idea. That's how you are better with R. Type them yourselves, and then if you make mistakes, retype them. You've seen me mess around with R in class. And then it says normal test, J equals JB, this is the JB test. So when you type this command, that's the JB test using F basics. This is the this is the language using F basics. If you use another package, this language, this syntax, I don't like to call it a language, this syntax will be different. And I showed you last week or 2 weeks ago to do exactly the same thing. I think I used 2 or 3 different packages in class, and you were all looking at me and laughing at me, ha 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 ha. So it's the same. But now you're using F basics. Because you're using F basics, this is the syntax. Okay, good. Now one final thing, and then I'll take questions. So on the next page, on the final page 27, if you type that, syntax up there, it will give you say, I'm sorry, it will say title Jacques Berra normality test. I mean, they make a mistake here in the spelling. Normality test. That's the same mistake. Okay, in the textbook, and then it gives you the chi-square statistic. Look at that, and then it gives you the p-value. Okay, so the p-value, this is, look, 2.2 times 10 to the negative 16. In other words, 2.2 divided by 10 to the power 16. I mean, this is as close to 0 as you can come. And if you're, well, normal, if you are not told, test it at the 5% level of significance. So this p-value is much smaller than 0.05. That means, do you reject or do you accept? Do you not reject the null? And so do exactly what I ask you to do in the homework. Okay? So look, everything you need is here. That's why I give you the homework. And that's why I give you that little R exercise. And from now on, that's what I'll be doing. So that little by little, you become a lot more comfortable with R. Okay? Okay. So now I'll take a question. I'll take questions.
Hi, Professor. I have 2 questions.
Who is this?
Roxalana.
Hey, Roxalana, how are you?
Hi, I'm good. How are you?
Fine, thank you. Yes, question?
So for this specific instance, since x squared is bigger than the p-value, that means you reject normality, right?
No, absolutely not.
Okay, so you only
Okay, hold on. Okay, that's a great question. Thank you for asking that, okay, Roxalana? All right, thank you so much. Now, so what happens is this x squared, really, remember I called it chi-squared, right? CHI, remember that? It's chi-squared.
Yep.
Okay, it's chi-squared. Okay, but it's you need to go into another area, into the equation mode, in order to write the chi properly. So chi-squared is this. Okay, now if you want to use chi-squared, it's like what in statistics, when you calculated the z from the sample, what happened? Then you went to the back of the book and looked up the critical z, and then you compared the z from the sample with the z from the back of the book, the critical, and then you make your conclusion. If you don't want to do that, then you use p-value. Now, if we want to do if we want to work with the chi-squared, okay, this chi-square is what? 2.4, let's call it 0.44. That's chi-squared. And what is, okay, it's okay. Let's walk through this. What is the length here? The degrees of freedom is df is usually 2 degrees of freedom. So we're looking for chi-squared, degrees of freedom 2, and 0.05. Okay. So if you want to use that, Roxolana, what you call x squared, if you want to use it, then we're going to so that x squared that we calculate is this chi-squared. That is the one from the sample, and now we're going to look for the critical. Are you with me?
Yep.
Okay, good. Now everybody hang on. Since Roxolana asked this, let's do that. Okay. Danny, remember you and I worked on this a few weeks ago. Hello, Danny. Danny is not here. Okay. Daniel was here a second ago.
Yeah, I remember.
Okay. So thank you. Okay. All right. So look, Danny and I went to the, that is after class. Danny and I, we chat from time to time after class. So we went to, so this is the command you need. So CHI. Roxana, what you call x squared is CHI, chi square dot INV, inverted dot RT, right tail, because the chi-square distribution is skewed to the right, okay? I will show you where to get this. So you might want to write this down, CHI chi-square, CHISQ dot INV dot RT. The 0.05 is the 0.05 is the significance level, and the five is the what was the five now? The five was the degrees of freedom, right? DF, okay. And our degree of what? How did we do this? This was for another example, okay. But for this example, whatever t was, let's just say the t was 100 and degree of freedom is t minus 2, something. So it's a large number. So if you want to do that, let's go here, okay? And I'll go to, everybody please watch me, all right? I'll go to this fx. I need a function.
Professor,
Yes, who is that?
it's Andrew. Your screen, we just see your file.
Oh, you don't see you don't see the Excel?
Nope.
Oh, I'm sorry about that.
You like
My
to
bad.
stay up late, I see.
Oh, you see the times I
Yeah,
do
it's
my
4
stuff?
a.m., 3 a.m.
Yes, I really never sleep. Okay, sorry about that. Thank you for flagging that. Oh yeah, I mess around. I play around a lot from 12 midnight to 6 a.m. That's what I'm doing. Okay, so you guys, so here, are you, Andrew? Are you seeing the Excel now? Okay, so at this point here, so I go here and I do fx, okay? Fx. So it's function, and what do I use? I use statistical. So let's look for, yeah, most recently used is statistical. Look, it's right here. But since I'm doing this from scratch with you guys, I look for statistical. I mean, many of you have done this before, right? I look for statistical and I say, okay. So I'm looking for a statistical function. Why? Because it's a distribution, right? No, I made a mistake. I think I accepted too fast. So let me do it again. Function. I want statistical function. Okay. So the question is, which one do I choose? All right. I know this because if for example I'm looking to find the probability under the curve. Remember when in statistics, when you guys did the z distribution, the normal distribution, and we wanted to find what is the probability that z will be more than 0.5%, then we're looking for the probability. In that case, we use z dot distr, okay? So if I was looking for the area under the chi-square, I will use chi-square period distr, distribution. I'm looking for the area under the distribution curve. But no, I am looking for the z value, the horizontal. Okay? I'm walking along the horizontal. I'm not looking for the area under the curve. I'm looking for the axis, the spot on the axis, okay? The critical value. So that's why I use this. I use this chi-square dot inv dot rt, okay? And then it says chi-square, you need to state the probability, in this case, the level of significance, 0.05, and the degree of freedom, okay? All right, so I say, okay, that's what I need. So I say probability, I'll do 0.05. I'm testing at the 5% significance level. For degree of freedom, usually degree of freedom is the number of degrees of freedom, a number between 1 and 10 to the power 10, okay, excluding this. So you can go for very large number. And typically, it's the number of observations minus how many statistics you are computing. So just for the heck of it, let's take, just for the exercise of it, I'm sorry to say heck of it, just for the exercise of it, let's do 100, okay? I think the t in that problem is very large. So let's just choose 100. So now I am asking you to find me the chi-square, the critical chi-square from the back of the textbook. And with that, I am going to compare the critical number, Roxolana, with my the x squared we calculated, which was 242.22. And look here, it already gave me the number 124. Wait, actually, I have another computer here. Let me check what the t was. The length, the sample size here is 2704. Okay, 2704. And if you subtract, how many things are we calculating? We're calculating the four moments. So subtract 4 from 2704. Let's call this 2700. Okay, 2700. So in this case, the chi-square is, oh no, why am I doing this? The degree of freedom is not. I'll check on that, because if I do this, then the critical is larger than I have to accept. But no, I'm not accepting. I'll check on this. Okay, I think the degree of freedom for this problem is not the number of observations minus 4. All right, I'll check on that. Okay, so but let's do. Let me go back and do the 100.
Professor.
Yes.
Professor.
What was the degree of freedom?
On the book, it says that the Jacques-Barrat test has always a degree of freedom of 2.
For 2, right?
Yes.
Okay. Okay. Why? Because, thank you very much, Danny. Because we are computing.
It's Alec. It wasn't Danny, Professor.
I'm sorry. Who is that?
Alec.
Alec. Thank you. It's because. Thank you. When you do regression analysis, the degree of freedom is n, your number of observations, minus how many coefficients you calculate minus 1. Okay, I just forgot about this is chi-squared. Chi-squared, again, you don't have to remember this, but if you look at the handwritten equation I gave you about Jacques-Barrat, right? I gave you Jacques-Barrat equation handwritten at the beginning of the semester. The Jacques-Barrat, we need 2 parameters to test Jacques-Barrat. We needed the what was it? The coefficient of skewness, right?
Yeah.
We needed the coefficient of skewness, and we needed the excess kurtosis. That's why the degree of freedom is 2. Thank you, Alec. Okay, so it's sometimes it's difficult to remember these things, but that's why we have the book. Okay, so here the degree of freedom is 2. Thank you so much. So here my critical chi-square is 5.99. So if I do that, the critical is 5.99. Roxolana, are you writing this down? 5.9 now. So now let's go and let's compare 5.99 to the chi-squared from the sample. The chi-squared from the sample is 2422.44. Okay. Mm-hmm. Does anybody have a question here before I leave this spreadsheet?
So if chi-squared is bigger than the critical value, then you reject?
If your sample chi-squared is bigger than this number 5.99, then that means, again, the chi-square distribution is like this, and that means your sample is way farther away than to the left-hand side, okay? That means you reject the null.
Okay, so if you
but hold on, what is the null?
That it's not a normal. No, the null is that it's a normal distribution, and you
exactly.
reject it, meaning it's not normal.
So if you reject that, it means it's not normal. If you fail to reject that, then you are saying it's a normal distribution, okay?
Okay, but if you don't want to use the chi-squared, we can use the p-value, right?
That's the point. That's why I make mistakes when I have to go from z to t to f to chi-squared, because it's sometimes very difficult to remember what the formula for the degree of freedom is. Okay, But if you use the p-value, you don't have to remember any of this.
Mhm.
You understand?
Okay, so if p-value is greater than like 5%, then that means that it's a normal distribution.
That means you fail to reject.
Okay.
And that means if you fail to reject the null, then what's your conclusion? Is that a normal or not a normal?
It's not normal.
It can be a normal.
Oh,
No. If you fail to
okay,
reject
so
the
it is
null,
normal. It is normal.
if you fail to reject the null, that means it's a normal distribution. At that, you are saying that at the 95% level of confidence or at the 5% significance level, there's a great chance that it's a normal distribution because you do not reject the null hypothesis. Okay?
Thank you. That was helpful.
Okay, so who was asking me the question? Was it Alec or Danny, or who was asking me the question?
I wasn't asking you a question. I'm a little bit confused about the p-value and the chi-squared. So when the p-value is smaller than the 0.05, which is our target p-value for 95%, when the p-value is smaller, that's when we reject.
Well, what are you rejecting?
So we are rejecting the null hypothesis.
Exactly. So when your p-value that comes out of the R program is very small. How small is small? Smaller than 0.05, right?
Right.
That means you reject the null.
Yes.
Okay. So you can either when I do my own research, I never use chi-squared or F or T or Z. I just look at the p-value. But because I'm a professor, I have to teach this. And so that's why I'm teaching you how to use chi-square by itself. When you're using chi-square with Jacques Beira, the degree of freedom is only 2. Not like I said earlier, T minus the number of coefficients you calculate. That's what you do in regression analysis in ECHO 4000, okay? But it is confusing to keep track of degree of freedom when you're jumping from one distribution to the other one. But when you use p-value, you don't need to remember any of these things. Just look at the p-value from the program, from the sample, compare it to 0.05, and then make your conclusion. All right, so here now.
Professor?
Yes, sir.
So my other question was about the
wait, who is talking? I don't see you.
Alec,
yes.
And it's about the way you want it formatted for the answers of the questions.
Oh, okay. Hold on. Before you say that, Alec, let me just show something, okay? Just give me a second. I'll come back to your question.
Okay, no problem.
Okay, Alec, I want you to look at this, okay? So suppose you and I have run this R program, and then we have used that command. We have used this command for Jacques Beira, this one.
Normal test.
Okay, the normal test, okay? So we use the normal test, and we get this result, this one here.
Yeah.
Okay.
Yeah.
So you can do it 2 ways. You can use the chi-squared. This is 2422.44, and then compare it to the one I just showed you, 5.99 on the Excel sheet, right?
Got it. Mm-hmm.
This 2.44, this 244.2 is much larger than the 5.99. So what will be your conclusion? You reject the null.
Yes.
Or if you don't want to mess with this number and going to Excel to look at that number, you simply look at the p-value. Now tell me, is this p-value large or small? Look at this.
It's almost 0.
It's almost 0. So is a number almost 0 larger or smaller than 0.05?
Smaller.
It's smaller. So because it's smaller, therefore your conclusion is that you reject the null. Is that right?
Yes.
And what is the null?
That the data is a normal distribution.
That the data, not that the data is that the data comes from a normal distribution.
Right.
Okay.
Yes.
All right. So what's your other question?
So the way you want the answers formatted, so is it okay if we put it like comments? How many, for example, you asked a question about explaining the first moment, the second moment, third and fourth moment.
Yes.
And my question is how many sentences you want an explanation for? How much in depth do you want us to go?
Hey, buddy, that's why it's a homework. Did I give you any time, any space limit?
No, but
Ah?
okay.
Yeah,
No,
there's a 1-page limit.
yeah, but I mean,
Anybody that
God.
gives me 2 pages, if you give me 1 page and 1 word, I would trash your homework. All right. Andrew, my buddy, yes. Wait, when you go to where? Ah, no, I want you guys to play with that. Mm-hmm. Okay. No, I'm not going to. Just describe it for me. Describe it in words. My computer will mess me up if I mess around now. Sorry. Okay, while Andrew is running his stuff, does anybody else have a question?
Yeah, I have one last question.
Roxana, wait. Where's Lily? Huh? Lily's missing. Can you guys tell Lily that she's missing from my class? So, Roxalana, the day you are not in class, I will know. Andrew, you. Danny, you. Alec, I will know. Where's my friend? You
I'll
know?
never miss a class, Professor.
Yeah.
Don't worry.
If I miss a class, you could fail me, Professor.
No, I won't fail you.
But if I
Of
don't
course.
miss a class, you gotta pass me with an
Oh, shut up.
A.
All right, Mr. Murphy, you here? All right, just chat me, Mr.
Okay,
Murphy.
so
If you're here.
can
Okay,
I-
yes.
I'm gonna.
Wait. Roxolana, ask me the question.
Yeah, so I hope this will have a quick answer to it. But so for normal distributions, the skewness is 0, and so is kurtosis, it's 3. Excess kurtosis is 0. But is there a difference if you do it with log returns? Like, are there any different, I guess, set of standards for it to be normal? Because I read somewhere online that for log returns, skewness doesn't necessarily have to be 0 for it to be
Again, read it in your textbook. That's part of the homework. I know what I'm doing when I give you guys homework. I won't give you 100% of the answer, but
Oh,
that's part
Professor.
of what I want you to check. Okay? Yes.
Okay.
So actually, someone in chat said I could copy the output, so I'm gonna do that. Wait. Sorry.
No. I don't want to answer your homework problem.
No. It's a question about the output.
About our output.
The output from the homework.
Okay, so talk to me about it. I don't
I
want to see it.
I got the symbol and then I ran it, and then the output so the very last column it says the stock name, which I did NVIDIA. So it was NVIDIA dot adjusted, but then like the price is like way off the close price.
Okay, so why don't you do this? And this is for tout le monde, to everybody in this class, okay? So if you use quant mod and you get a weird looking number, if you get weird looking numbers, what do? You go to yahoo.com, go there and physically check, because if you go to Yahoo, I went to Yahoo in this class last week. Go to the adjusted close column and check it out. Make sure it matches your number. Okay. Yeah. I mean, I don't have to tell all. I'm sure you know how to do this. So use quant mod, but as a way of checking, go ahead and go directly to Yahoo Finance and check for your whatever stock you chose. Check the adjusted close column. Make sure your numbers match. If your numbers match, it means that quant mod actually went there and picked it up. Okay, Danny? So Andrew?
Yeah.
Danny is in my head always. All right. Any other question?
Oh, yes, Professor. Hi. I have a question. So like Saturday is like, it's a hard deadline, right?
Saturday is a very hard deadline because this homework, I already assigned it to you 2 weeks ago for you guys to play with all these commands. In fact, this homework I was going to make it due on a Thursday night. But I said, you know, students are students. I was a student before. Let me make it to Saturday, because remember, we have to grade them and we don't want to take 3 weeks grading them, okay? So guys, Saturday is very hard deadline. And it's not midnight, it's 11:59 p.m. So please don't wait till midnight. At exactly 11:59, Blackboard cuts off, and you cannot, if you submit, it will mark you late, and then you'll be penalized, okay? Because immediately after that, I'm hoping to give you another set of homework.
Okay.
Professor.
Ian, you said you can copy compiler output here. Yes, but for this, Ian, but for the submission for the homework, I like for you guys to copy Word and put it in Word. Okay. All right.
I don't know. He was replying to me that for me to explain what I was talking about.
Okay. Okay, yes, I know that. Okay, thank you. But what I'm saying is, because some of you are more advanced than others, so I want a level playing field for the class, and we're going to be working our way up. By the way, can you everybody tell me? I mean, tell me if it's true. Tell me if it's not true. Was my explanation of this homework helpful to some of you? To many of you?
Yes.
Okay, so I'll be doing this in the future. Okay. So once this homework is done on Saturday, once you guys all submit on Saturday, maybe on Sunday, I'll post another homework. Nothing big, okay? Nothing big. And the idea is I want to post on a Sunday or early or sometime on Monday, so that you guys at least get your hands, spend a few minutes with the homework before class on Tuesday, so that you can bring your questions to class on Tuesday, okay? So I'll typically will give you time enough. So if I post it on the Saturday, if I post it on the Sunday, I'll make it due the following Saturday evening. And believe me, you can do it within that time allowed, because the homework will not be large. If the homework is large, I'll give you 2 weeks. Okay, I'm not a monster. Okay, all right. So this homework, just follow the commands here and do a little bit of more Google investigation, and then submit everything by end of class. If you still have a question, you can ask me 2 days from now on Thursday. Okay, guys? But I want us to be able to be doing this homework like this, step by step like this, so that you get familiar. And for me, one thing is for you to be able to just, mechanically, robotically, type the commands, and R will give you the output. But I also want you to be able to interpret your answers. So for example, in this example, if you go here, you look at the mean. Look, this mean, the mean is 0.00002. What does this number mean? Don't just tell me that the mean is 0.0002. No, that's not what I want. Okay, if the mean is 0.5, 0.03, what does 0.03 mean? That's what I want, okay? When I say explain, that's exactly what I want. Okay, so I'm going to move on. Yes, Baghdadi, yes, okay, all right. Okay, and again, all right, so yes, Baghdadi, I agree. Okay, any other questions?
Oh, yeah, yes, Professor. My question.
Nadia, yes.
Yeah, you missed me.
Wait. By the way, hold on, everybody. When I give homework like this, I may not be using up my class time. Maybe I'll use maximum of 10 minutes to answer questions on homework, but I need to teach stuff. So the class TA, Chan, is going to be having office hours. Did she send you email already?
No, she has not.
Okay, she'll be sending email for her, giving you her office hour times. So many of these questions you can ask her during her office hours. But I'm just doing this today because it's the first homework. But the second homework, maybe next week, Tuesday, I'll just take 10 minutes just to point out a few things, maximum 15 minutes, but then I have to teach my class, okay? That's why we have a TA, okay, guys? All right. But today it's okay. I'll take questions. Nadia, go ahead.
So we have to take a company which like have been traded since 2010, right?
Yes,
So for example,
any question, any company you take has to have existed before the time I gave you, all right?
okay.
And
Yeah.
and again, look, you guys can play games. This is Echo 4000. So most of you are seniors. You are graduating at the end of this semester. I hope all of you are graduating. So you can play games. You can, you and your friend can work on exactly the same company, and then I copy what my friend does. My friend is doing it and learning, and I'm copying from my friend. I'm not learning. So again, everybody's an adult. You make the choice. Okay. If you just choose to just copy whatever I copy whatever you do, you are learning, I'm not learning. That's my own. I paid for the school and I'm not learning. That's my business. So everybody is mature. I leave you to police yourself. Make sure you are learning stuff. So I don't want all of you to go choose Apple, because it's in the textbook and 5 of you, one person does it and 4 other people copy it. Don't do that. Okay, I'm not saying you would do that, but please, if you guys learn R from this class and you go into the industry, you are way ahead of your competition, because this is a class of over 2.5 months for you to mess around and learn R. And this is where you make all your messing up and your mistakes and everything. And I'll help you. The TA will help you. Your classmates will help you. But for homework, I'll ask you to choose your own company. You can work with a friend, but if the friend is working on Microsoft, you choose NVIDIA, 2 different companies. You guys can talk. Oh, how did you do this? And you can, but do your own company yourself. Okay? This is very important to me. And I know when students play games, I see that, but that's unfortunate because you're cheating yourself. You're not learning what you're supposed to learn. Okay? So if you have a problem, bring the questions to class or take them to the TA. Between me and the TA and I will help you as much as possible. But if you learn R coming out of Baruch, by God, you are ahead of your competition. All right, sorry, I just had to preach that. All right, any more questions before I move on? Okay, so let me move on. So today, before the end of class, I want to show something else to everybody. It was an assumption I made before this class that you guys had that prerequisite, but from the questions I'm taking from everybody, I should not have made that assumption. So I'm taking a step back. And what do I want to do now? I want to discuss, because when I teach a class like Echo 4000, a class at the level of Echo 4000, I take 1 or 2 class periods and I discuss data, different kinds of data, time series, cross-sectional, cross-sectional time series data, panel data. When we do econometrics, statistics and especially econometrics, like at the level of Echo 4000, we use different types of data. And when I teach a class like Echo 4000, at that level, I discuss the different kinds of data we use, okay? And I kind of assume that every teacher would do it exactly like I do it, but not every teacher does it. They don't need to do that because their syllabus may not say so. So it was wrong of me to assume that knowledge before you could. But since over the past 2 weeks, I have been listening to questions many of you have been asking me, and I decided, let me go back. So in the next few minutes left, I want to go back and show you what I like to call the components of a time series. What this thing we call a time series, what does it really look like? I mean, what is it made of? Okay. For example, I ask you guys, describe a human being. What are the components of when you look at a human being, what are the components of a human being? Well, most human beings have 2 hands, 2 legs, 2 eyes, 2 ears, nose with, mouth, and so on. All right. But in addition to the hands, the arms, and the legs, 2 legs, 2 that's most human beings. I know some of us are different from others because of accidents and stuff. I'm just talking the average human being. But then, Danny, I haven't seen you standing up. You haven't seen me standing up. But you and I presume you have 2 arms. I have 2 arms. You have 2 feet, 2 legs. I have 2 legs. You have 2 ears. We have the same components. But what then is different from you and I? Well, we have all these components, but maybe you are taller than I am by accident of nature, by peculiarities of nature. You are taller than I am. So every human being has basically arms, legs, ears, eyes, and so on. But then plus or minus height, that's random. Okay, so you can see 10 different human beings. All of them, each of them has 2 hands, each of them has 2 legs, 2 ears, normal stuff, average stuff. But then some of them, Manute Bol is like 7 feet tall. Me, I'm just, barely 6 feet. Somebody else is 6'5". So even though all the 10 human beings have the same, components, but some of them are, the height is random. The same way for time series. Each time series has something that is regular, that is common among all of them. Before I show you my PowerPoint, let me show you this graph, okay? On page, let's see, I think it's page 13. Okay, so there's the R demonstration I showed you earlier. Now, if you plot the series, chart series, okay. So on this page, guys, look at the time series. Look at the time series. Look at this time series. Look at this. Okay, this is time series of prices, time plus of daily prices and trading volume. So this is volume below. But let's look at the price, right? Look at this price. It goes up, 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 up. It comes down. It goes up, up, up. It comes down. It goes up, 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 and so on and so forth. Okay. So this is the time series of the price of Apple stock from January days to December days. Now let's go down and look at another time series. This is another time series. This one here. What company is this? I'm sorry, this is monthly unemployment. Okay, US, in the United States. Now, let's look at those 2 time series. Okay, do you see anything common between those 2 time series? Does anybody see anything?
They have variation.
Yeah, they have variation. So this one is unemployment. This one goes up, it comes down, it goes up, it comes down, it comes down, it goes up, it comes down, it comes down. But there's a trend, right? You see this trend here, right? And then it trends up, and then it trends down like this. Okay. So here, look, this one trends up, but on average, this one is trending up. On average, this one is also trending up, but maybe at a lower slope. Yes? Okay. Let me show you another one. Where is the other one? I don't see it here. Hold on a second. No, there's another one. Let's go to page 14. Okay, this is one. This is another one. And on page 15, I think there's a third one I want to show. Just bear with me. My Adobe Acrobat is locking me up. Okay, so let me go to page 15. Okay, look at another time series. This is time plot of Chicago interest rates, okay, for 10-year treasury. How is this one different? Anybody?
Has a downward sloping trend.
It has a downward trend. It's trending downward. Does it have variations? Yes, it has variations. Okay, it has so one thing you can say for every time series has some kind of trend, either positive up or positive down, and some type of variation. But people who have studied time series, for a long time, have told us that a typical any time series can have up to 4 components. 4. Okay, so now I'm going to go to my PowerPoint here, and guys, I'll post this PowerPoint, maybe not today, but at the end of the week when I'm done discussing everything here. Give me a second. Let me look for the PowerPoint. What time is it? Oh, okay, we have time. Okay. So I have compiled this, and what I'm doing is I'm going to the internet and I'm going to YouTube, and I'm looking for, from sources of the message I want to give you, and I'll compile them together, either on the PDF or in a PowerPoint, and I'll post at the end of that lecture series. Okay, so let me show you. Let me show you the components of a time series. Okay. Okay, again, I'll post this PowerPoint on Blackboard when I'm done. So a time series has 4 components. I got this from the internet. I mean, there are beautiful things on the internet, but I'm just extracting from different points, okay? So a time series has a trend component. Now that trend can be upward, positive, or downward, negative trend. It has cycles, a cyclical component. It has seasons, a seasonal component, and then it has a random component. Just like for the human beings, if 10 of us from this class, we have all those components I said. Everybody has 2 hands, 2 ears, and all of that stuff. But then each of us may have different height because that's a random component, okay? So each time series has trend, has cycle, has seasonal, and then has irregular. So if 2 time series, for example, Apple and Uber, over the same time period, they may have positive trends, or Apple might have a positive trend, Uber might have a negative trend, but they each have a trend. They may have cycles or not. Apple may have cyclical component, and Uber may not. Just like 2 human beings, you may have 2 hands and two legs. I may have only 1 hand and 2 legs, maybe because I lost my hand in an accident, or I was born without my right hand. I mean, so in other words, these are all the 4 possible components of a time series. Okay. I have included this equation. So a time series, this y, and again, you can put time series y parenthesis I, I for the subscript. I didn't put it here. So a time series has these 4 components: the trend component, the cycle, the season, and the irregular. In econometrics, we call this irregular, but this is the random component. This is like the error term, epsilon, in regression analysis. So we call it irregular. It's random, okay? Okay, so let's go here. What is the trend component? The trend component is persistent, it's long-term, it's a long-term feature of the time series. For example, if you go and download IBM price for the past 100 years, okay, you will see whether over time the price of IBM has been trending up or down. Let me give you guys an example. Suppose in the year 1900, we went and collected the level of the Dow Jones Industrial Average or S&P 500 in 1900. And every month we collect that data up till December 2020, and you plot it. Price. What do you think? Will the price be trending up, or will it be trending down over that from 1900 to 2020, month by month? What do you guys think?
Trending up.
Of course, it's trending up. Okay, but for some time series, when you plot them, just like the one I showed you, employment or unemployment in the textbook, some time series will be trending down. So the trend is the long-term feature of the time series. Okay, so let me move on. I have a few more minutes, so I'll post this, so you don't have to worry too much. So the trend is like this. Okay, so if you have a time series like this, and you can draw this red line as a trend, that is typically what we want to do when we do OLS regression. We want to find a trend. All right, okay. What is the cycle? The quickest way I can explain the cycle is like a business cycle. Do you guys, how many years does a typical business cycle last? Anywhere from 2 to 10 years. Guys, when was our last recession? It was in 2008, yes? Yes? Okay.
Yes.
2008. And then from 2008 to 2020, we have a brief recession from pandemic. But without that pandemic, we could have gone maybe 20 more years without another recession. And that is what we call a business cycle. Remember from your macroeconomic studies or from your 4710 studies. So you have business cycles, they go up, expansion, and then this, and then it goes to the peak, and then it declines, and then it goes into recession, and then so a business cycle from recession to recession could be anywhere from 2 years to 10 years to 20 years. But on average, this cycle is a repeating up and down movement. Look, unlike the trend is not repeating. The trend is persistent, overall upward, or OR, overall downward. It's persistent, either going up or going down. But the cycle is repeating up or down. So it goes up and then comes down and then goes up and comes down over reasonably long periods, intermediate 2 to 10 years. That's the cycle. The most famous example is the business cycle. Then the season. The season is like, if we want to track the sales of Coca-Cola, if you are taking the price of Coca-Cola stock. Now, Coca-Cola, you guys tell me, when do you think people drink the most cold Coca-Cola?
Summer.
In the summer. So from summer last year to summer this year, you will see a seasonal trend from Christmas to Christmas, from summer to summer, from winter coat, winter to winter. Those are seasonal components within 1 year. Okay, so the trend is long term, either up or long term down, trending up. Then the cycle is intermediate term from 2 to 10 years. And then seasonal from Christmas to Christmas, winter to winter, summer to summer. So every time series has either the trend, the cycle, the season, or all of them together. But then if you have two time series, IBM, Uber, okay? If they have exactly the same trend, exactly the same cycle, exactly the same seasonal variations, that's a random component. That random component will distinguish two of them. Okay, now everybody, please let me say this last thing before you leave. Again, I'm going to post this at the end of the week. Okay, so the irregular component is called the erratic on systematic. That's what you used to call residual in statistics. Now, everybody, please look. I'll say this one last time, and then you can leave, okay? Thank you for bearing with. Okay, look. Everybody look at here, please. What happens if this 3, TCS, if I say Y, I move this TCS to the left-hand side. So I say Y minus T minus C minus S equal to what?
To I.
Equal to I. And that, remember, that's what you call residual. Are you with me so far?
Yes.
And what features do we want our residuals to have? Our irregular, our random component. We want them to have average of 0, right? Wash out. The observations above the line to be equal to the observations below the line. So it will have a mean 0. We want it to have constant variance and so on and so forth. For in this class, time series, that's what we call a white noise. So you can think of a white noise as a time series, this time series for which we have removed the trend component, we have subtracted the cyclical component, we have removed the impact of the seasons, we have removed all of these 3, and what is left is the irregular random residual component, and we want it to be well behaved, to have no pattern, average of 0. Constant variance, not variance up, variance down, and not small variation here, large variation here. No, we want the variation to be constant, 0 mean, 0 correlations, everything. That's what we call a white noise. You understand? Okay, I'll stop here and then I'll continue next Thursday because from white noise, then we add the trend and the cycle and the seasons to make the either autoregressive and so on and so forth. So beginning with the white noise, we can add the trend component. That's the time series that is not the white noise. We can add the trend and the cycle. We can add the trend, cycle, and season. Okay, or some time series have only the white noise portion and the trend portion. Okay, so from now on, your next exercise, I will ask you, go take a time series and tell me if it's white noise. Okay, and then after that, we shall then build the AR model, autoregressive model. So I can ask you, because the autoregressive model would be some component plus the white noise together. Okay, so after that, I'll give you homework. Tell me if it's autoregressive, or tell me if it's moving average, and so on and so forth. Okay, so don't forget, the white noise is the pure form of the residual. We want it, to average 0 at the end of the day. We want the variation to be constant. We want there to be no correlation. That's what we call IID, independently identically distributed, and so on and so forth. So the purest form of time series is a white noise. Okay, all right, good. Let me stop recording.
The recording has stopped.
Actually, I paused it. Let me stop it. Okay. All right, guys. So thank you. I'm sorry I took 5 extra minutes. Sorry about that. So I'll see everybody on Thursday. On Thursday, I'll review again white noise. Then I'll go into autoregressive. Okay. Autoregressive, and then we'll build up better. Thank you. Thank you, Alec. Good night. Bye, Ian.